Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre, with me is Z. Today, we have some topics around some bug bounty program changes with Chrome, as well as some more methodology-focused topics around fuzzing and some vulnerabilities sprinkled in there. So I guess we'll start off with the Chrome VRP updates. So yeah, we have the page up here that talks about the timeline a little bit, but few days ago, or I guess a week ago now, Chrome updated, or Google, I should say, updated their scope and introduced the Sandbox escape as an in-scope submission and changed the rewards up a little bit. So the relevant points there are they reward up to 250k for Sandbox escapes or RCE and non-Sandbox processes, or 85k for a highly privileged process, like the GPU or networking processes, and then 55k for renderer RCEs that don't escape Sandbox.
So yes, but I don't believe that's new at all. What is new are the Sandbox, or what I believe is new are specifically the Sandbox bypass rewards. Which is
they do have bonuses and stuff too. Yeah,
well, these aren't bonuses. This is just demonstrate a memory corruption outside the V8 sandbox is $5,000, and a controlled write outside of the V8 sandbox is $20,000. Those are what I believe was recently added. So I guess it does mention here V8 sandbox is introduced, or sandbox bypass was introduced in April 2024, but as of November 2024, we're extending the reward to include all memory corruption demonstrated outside the V8 sandbox.
Right, okay.
That specifically seems to be the new update there. Like, I believe, I'm not sure if the values changed because I definitely don't keep those memorized, but I believe the ones you did mention are like up to 250,000. That feels like what it's been for a decent chunk of time. Like,
yeah, so we were actually talking about this a bit before the going live, but it's a little bit hard to tell what's new and what's not with the way that their VRP page is set up, because all you have for their news and updates really is this like bullet point listing, which actually we didn't really find until today. So yeah, it was a little tough to tell what was new and what wasn't. So yeah, fair enough. It's the memory corruption outside of Sandbox rewards that were added. Okay.
I think it's great. Like, I've really appreciated what Google's been doing with kind of their CTF payouts here, because like all this is requiring for you to demonstrate is that you have a memory corruption. They're not requiring that you actually have a full Chrome exploit or like V8 exploit. They actually have like a memory corruption API that you could use. You have to build this in. It's not like provided by default in Chrome that like emulates the primitives that you might have in the browser, like read-write primitives. So kind of what they're going for with a lot of these is just making it easy to find and demonstrate the bugs themselves, because of course to fix the bug and to secure the software, you don't need to write an exploit. You just need to show primitives there. That's probably enough. Like, if you have read and write, you're probably going to be able to get an exploit out of that. Just be able to do that. And there's so much effort that goes into exploit development that exists on just like knowing the right structures to compromise and doing the grooming around that, and doing all that sort of coercing and magic, basically, like getting that right incantation for your bug to work. Whereas what they've been focusing on is just making it a lot more practical to demonstrate there is a bug, with things like this, where they also have, it's documented on another page where it talks about the sandbox itself, but like you could also build with a special signal handler that you can either build with sandbox testing or sandbox fuzzing. Puts a signal handler there to actually determine, like, was this a segmentation fault? Was this a violation of the sandbox itself? Did you break the sandbox with that? Trying to even automate a degree of that. And I think like their KVM CTF has like, if I recall correctly, it's like you need to either be able to read a specific address or like read a register or something. Like, it just has like the data worked in to the application itself to make it easy to just prove there's a bug here. Because we've talked about quite a few times where, people are going to be like, well, is this really a bug? Can you really exploit this? And Yeah, I think they've taken some really interesting steps towards just being able to show you, like, making it easy to show that impact without requiring that you actually become like an expert in V8 exploitation, because it is very complicated. There's a lot of depth to that that isn't necessarily needed just to find the bugs. Not to say that all the bugs are just
Or demonstrate
super.
the impact. But yeah.
Yeah, like, it's not to say that the bugs are always superficial or something. There are some very deep bugs too, but the knowledge between vuln research and exploit development is different, and so it's just making it more possible, and they pay out pretty decently too. So yeah, I
Yeah,
kind of like seeing this sort of update.
I would say in browsers particularly, the exploitation and VR skills are pretty separate in my experience. Like I think it varies a little bit from target to target. There's some targets where if you understand the code base well enough for VR, you probably at least have a pretty good idea of like what an exploit strategy would be and how you could implement that. With the browser, it's a little bit different though because it's just so much to chew through. So yeah, I mean it's really cool what Google's done with like doing a hybrid of CTF and bug bounty. It's really smart, and I haven't really seen anywhere else do it yet. It seems like only Google's been doing that with like uh kernel CTF, KVM CTF, V8 CTF, all of that stuff. I haven't really seen it anywhere else, which maybe that'll change because yeah, I think it's a really like smart idea and it can save a lot of time on everybody's part. It's just a really efficient way to do it, and it gamifies it quite a bit too. So
Yeah, and I just have to be sitting here. I'm going to assume that this is just a typo, but there isn't a product called D8, correct? It is just V8. Because we've got the active release channel of Chrome, or D8. I'm pretty sure that's just a typo, right?
I think so. I haven't heard of
Yeah.
D8.
No, no.
Oh
Well,
no,
I
no,
mean,
no. Okay, D8 is a thing. D8 is V8's developer shell.
okay, fair enough.
So you use it for like running scripts and debugging like the JavaScript and stuff. So
Okay, so I guess it's not a typo. Fair enough. I just didn't
today I
know.
learned. I didn't actually know that either. I just
I just
was
kind
able
of
to find
saw
it
that
quickly.
there and assumed, okay, maybe it's just a typo. But yeah, it makes no difference. In terms of what they're doing, though, one of the other updates, and we kind of talked about this a little bit before coming on. I'm not sure if we want to go into it now with their handling of dupes,
Of what? Sorry.
of duplicates.
Oh, duplicates. Yeah. So I do kind of want to talk about it because I don't remember us talking about it before. Maybe we did, and if so, I apologize. But if we did, it's probably been a while, regardless. But
Yeah, it's a
yeah,
January
so
update, so like it is a bit dated. So if you're doing bug bounty, you probably already know, but it does look like it kind of missed us. I remember something similar from fuzzing, but I'll let you take that.
yeah, so bug bounties have always had that kind of weird problem where you have the potential for collision. And generally speaking, the rule has been for most bounty programs that the first person who submits the vulnerability is the one who receives the payout. There have been some other strategies of handling it. I believe Mozilla maybe did like a split payout. So like if so many people reported the same issue within the same like a given time span, they would split the payout among those reports. But the way Google had changed it earlier this year was they have this concept of an actionable submission. And the whole idea is the first report that's considered for a payout has to reach a certain criteria of being able to be like reproducible and have enough information for triagers to work with. So if you have like someone who reports the bug afterwards, but it has a lot more information that leads to the bug being fixed, then that one is going to be treated as the actionable report. Furthermore, even if the first report that was submitted is technically considered actionable, if you submit a report after the fact that, like, not after it's already been patched, obviously, but if you have a collision, but your report is higher quality and provides some value in helping them fix it, then they will also reward you, even though it wasn't the first actionable report. So again, I mean, we've kind of said it before, but the way that Google tackles rewarding researchers and stuff is very nice. And it's pretty nice for everybody involved. It solves some of the problems that has plagued certain VRPs for years. Now, of course, Google is in a better position to do that. They have a lot more resources and are willing to throw a lot more resources at security than a lot of other companies can afford to. But yeah, I thought that was a little bit interesting with the actionable classification and kind of offering the bonuses for reports that help them, that even if they're reporting the same bug. It kind of makes you not feel like your time is as wasted, I guess, as a reporter too.
Yeah, and it's a take, or it's an approach that I'm not sure. Like you mentioned, Fire or Mozilla did the multiple pay, they'd split the payout if they had multiple bugs inside of like a time window. And Google's also done something similar with their fuzzing system, where like they make an attempt at trying to be fair with duplicates, although with the fuzzing one, that's also a little bit challenging because like they schedule the fuzzer, so it's also there to like make it fair. That's not just like your fuzzer ran first after this code was added or something. And that's why you got the first payout. But yeah, I mean, it's an attempt to solve that problem. Doesn't necessarily solve everything. Like one of the, I don't know how much this happens with Google specifically, but one of those common issues that people have is like the either won't fix or slow fix bugs, where it's like, the bug exists, it gets reported, they work on it, they report it, and it's like, oh yeah, we know about this bug and we're just not going to fix it, or we're in the process of fixing it for the last like year or 10 months or something. And of course, then you get a lot of duplicates when it's open for a long, when it's like still there for a long time. I don't know how much of an issue that is specifically with Google. I haven't looked at that, but it's another issue. But on a whole, actionable, like it encourages higher quality reports, but still kind of reporting, because part of the problem is you don't want people necessarily holding back their reports, be like, well, there's this, but I need to do all this extra work before I report it, and then losing out. So this does encourage taking the time to actually do your reports, but you can also update. Another thing Google does is they will try and figure out what the worst case scenario is for a bug that you report. And so even if you didn't find the way to exploit it, or like something that you could access, they'll still potentially pay out a larger bounty because they see that you could do something. Like they're not trying to screw
Yeah.
you on the bounties, which maybe a lot of companies kind of are. Or
Yeah, I
trying
mean,
to not
typically when
pay.
you see on a lot of bug bounty programs, it's companies trying to downplay the issue. It's not very often you see them upplay the issue and kind of treat it more seriously than even the researcher does. But yeah, it's a good step to take because, like you say, it makes researchers less hesitant to hold back on reports where, if they want to try to maximize and make sure they demonstrate maximum impact so they don't get screwed on reward, that 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 is a bit of a problem for like their objectives with the Vuln research program. So yeah, I mean there's a lot of cool stuff there, and that's a good thing to mention too with like raising the bar for acceptable reports, because Microsoft, for example, has in their programs, they have kind of a similar thing where they'll have a higher payout threshold for higher quality reports, and lower quality reports will still be accepted, but they won't be paid as much. But if you just raise the bar for like an actionable report in general, um, again, it kind of makes it so that you're more confident in submitting your report, even if it's, takes a bit longer or whatever. You're not worried about missing out, so to speak. So, yeah.
Yeah, I mean, it could suck though to also be a researcher that reported something and somebody else comes in after with like the better report or like more things figured out.
Yeah, but from what I'm reading, like that wouldn't detract from your payout necessarily. Like I don't think they split it. Uh, this like
Yeah, fair. I think I made
I
that
think it's more
assumption
of a
here, but they
bonus.
don't actually say that.
Yeah, I think it's just like a bonus paid out to the other report if it provides useful information. It's
I'm not sure. So I'm looking at qualifying vulnerabilities. Only the first actual report of a given issue that we're previously unaware of is eligible. So it's kind of saying like the actionable one is the one that gets the eligibility. And generally, the first one is first. But given these updates, like the update on actionable does kind of mean that somebody could submit a report with better information.
yeah, I mean, so the point that I was getting at was this one where they say So while this is against the core foundations of our policy around duplicate reports, we have made numerous exceptions and issued a small reward to the later reporter for their contributions that result in getting the issue resolved. So,
Oh, gotcha.
and yeah, when a later submitted report is of higher quality and is actively used, both reports may be eligible for a VRP reward. Okay, so they do divide it between the two reports. So I was actually kind of wrong on that.
Yeah, and that's
I
what
thought it
I
was more of
think
a
their
bonus.
policy has been for little, because that ties into that fuzzing one.
Yeah,
Like how they've handled duplicates in general, which I think is kind of fair. I don't know. I mean,
it's hard to
they're
make everybody happy in all
yeah.
situations,
I mean, when you
but
think about it, the bounty is for the bug itself, and so multiple people, it gets split. Like it's fair. Of course, I'd like if they just paid out like fully to every researcher, but that is a little
that's
bit
maybe not
impractical,
realistic.
and
Yeah,
that could definitely be abused. Like get a friend to
100%.
report the same bug and double your money.
Yeah.
So or
It's
maybe
unfortunately stuff like that that kills a lot of these like good faith signs. So yeah, hopefully that doesn't happen. But yeah, it could for
yeah.
sure, especially if you had it structured that way.
Yeah, I mean it is a bug bounty, so the bounty's for the bug, and they split it so that like I said, it's fair, but yeah, they're making some attempts here at trying to solve some of the problems and trying to make it clear. I think. 'Cause, I mean, I've seen a lot of bug bounty reports that just aren't actionable. They're just like, you do this, Burp tells me this isn't good, so give me money, and
Yeah,
yeah, it's. I mean, that's more
especially with
vague bounty,
browsers
but
because browsers it's very easy to show like low in or show like basically no security impact bugs and try to play them up because I mean you can write JavaScript that runs a loop 100 million times that allocates arrays or something and crashes the tab because it runs out of memory, and it's like that's not doing anything useful, that has no relevant security impact, but it kind of produces the same behavior as like what a memory corruption bug would do as well, which is causing a crash. So you kind of have that problem in browser. And again, kind of jumping back, introducing that memory corruption API and stuff is very nice for that, for trying to separate the wheat from the chaff of like which bugs are actually useful and which ones aren't. So yeah, some very great steps being taken by Google. And yeah, I mean, we like to talk about their CTF when they make some updates, and it kind of lets you get into doing some VR in an area where it can be very hard to break in and kind of go full stack, like trying to take a bug to full exploit and then also maybe trying to chain exploits is just very hard in modern browsers. But they have it set up in a way where you can kind of take it piecemeal and submit something that's maybe a later stage. So yeah, that's awesome.
yeah, and you just reminded me there. The Edge, Microsoft Edge, or Microsoft Browser Vulnerability Research Team, they've put out a couple posts now about security bugs that aren't being browser security bugs that they've had reported that they don't actually consider bugs. When you're talking about, it's easy to kind of find some of these sorts of things. They've actually done a couple posts on that, so we're going to bring that up quickly. And I'll just really quickly mention, because I think we mentioned the announcement for the KVM CTF, like there it's coming, but I don't know if we actually gave an update on like the fact that the KVM CTF actually, when it did launch, because I think they fully opened that up during the summer.
Yeah, they
I've got
did.
the post here that's from June. So I'll also mention that they do also have the KVM CTF, and like they pay out on like just having the ARM memory read and write and relative memory rate. And like if I recall, the way they actually test for those, like they have the value in memory, read it or modify it, and like that's how they.
That sort of flag idea still. Yeah.
Yeah. Um, Similar with what we're talking with V8. So I'm just going to shout out the KVM one also, in case anybody's interested in that. Do they have another CTF? Obviously, they've got kernel CTF, which that's been like the long running one. KVM CTF, V8 CTF.
I
Um,
think those are the major one. I can't think of any other big Google product that has its own
yeah, just
CTF.
trying to give a quick Google here, to see if there's something maybe
Like, I don't think they
I
have
don't
like
see
an
anything
Android
else.
or AOSP CTF, which is kind of interesting. You'd think they would, but
Well,
that's like the one big product where I don't think they have.
they have the kernel CTF, and then they have like they have those different tiers of like the three kernel CTF boxes,
Yeah, but
and one
I'm
of
talking about
those
AOSP user space. Like, there's a lot of code there that, you
oh,
know,
like all the services, like doing
yeah,
privast by a service.
yeah. I
Yeah,
wonder
I
if we'll
don't
see one for that.
maybe could make sense. Like that is definitely. Although I guess they do. Well, they have a general like AOSP bug bounty though, so it's not like they don't pay out bugs. But yeah, they don't have the CTF styled one, which maybe would also just be hard because that is device side.
Yeah, yeah. And vendors are gonna have their hands in that and everything. So maybe it's just hard to genericize and make into like a CTF sort of deal, but would be cool. But yeah, I
Either
mean, we always
way,
like to talk about the Google CTFs, and they are, I think, a good option if you're looking for something to do that has monetary reward attached to it.
yeah. Well, one of the things I like with kernel CTF in particular, can't call it KCTF now anymore. Although I think KCTF was also the name of their platform for hosting some things.
Yeah.
Anyway, with kernel CTF is also that they did pay out on exploitation and like end day exploits, which I don't think is the case for V8 or KVM.
As far as
Um,
I know.
yeah, although kernel they did, and they kind of had that. They had that little book, the cookbook, for the kernel
Yeah.
CTF, which they have a. I'm
I
just
don't
taking a
think
look if they
that's
have a cookbook for like V8 CTF because that would be kind of interesting.
yeah, I think I looked for that and I don't think they do, unfortunately.
Yeah, because as somebody that's not like in that realm of doing like the V8 exploits, I'd kind of be interested in that, in seeing that sort of breakdown of exploits from V8.
Mhm.
But yeah, I
Again, though,
don't.
with the nature of browser, that would probably be really hard to do compared to kernel. Like kernel, you typically have pretty standard interfaces, whereas with the browser, it's like
You still have pretty standard like exploit strategies past a certain point.
past a certain point, yeah, but like your initial primitive is gonna change a lot, especially when you're talking about like a lot of the bugs coming from like the optimizer and stuff nowadays. It seems really hard to like summarize or give a brief of like what your initial corruption is and what your capabilities are because you have to take advantage of so many different things in the engine. So
Well,
yeah,
you
yeah, I could
still
see
end
it being
up
harder to
with
do a cookbook.
I don't know. I mean, you still kind of end up with a lot of those same core primitives. Like, yeah, it's bad optimization leading to use after free, like not refs counting something or whatever like that. But you still end up with a lot of time those same core starter primitives. Like, I don't.
Right, but what I would say there though is that your primitives are in kind of different areas because like in the kernel for example if you get like a kernel heap corruption it's kind of pretty well understood what you can do with that and what directions you can go. You do sort of have like vmalloc areas and areas that aren't like the common heap but that's sort of rare in the browser though. Like you have the javascript heap, you have the dom heap, you have like all these different allocator, like you have multiple allocators, where you don't really have that in a lot of other applications or even in the kernel, or at least not in like it's not relevant most of the time. Whereas with browser, it's relevant like all the time. So that's the kind of thing that I think might be difficult to capture in like a cookbook style
Yeah, I don't
summary.
know. I could still see it, but I am speaking as somebody very much outside of the realm. So I could just be looking as like, oh, that's easy. That's no problem. Like they'll do it just fine. And it's actually no, like that could just be my inexperience going, but it feels like with enough exploits you'd kind of be able to start grouping things, like you may have more divergence.
Yeah,
But
and to be
doesn't
fair, I
matter.
will say also that I don't really consider myself super in touch with browser exploitation nowadays. I have written a few browser exploits and whatnot, but that was some years ago at this point, and browser security and mitigations move so quickly that you know, it's pretty different now from even when I have done it before. So I don't want to make too many claims, but like with my understanding of what I've seen, it seems like it would be a little bit hard to genericize.
Yeah. I mean, regardless, they don't have that available. So Maybe
Yeah.
they will in the future, because I mean, kernel CTF I think ran for a while before they put that out, and both
Mhm.
KVM and V8 I think are just from this year. Well, I mean
Yeah, I
KVM,
think
as we just said, I think V8 came just before it.
yeah, I'm trying to remember, but I think you're right. It is fairly recent, I think. I'm just looking at the Git repo actually. Yeah, so it was from the end of last year, it looks like. It was when V8 CTF launched. So, which makes sense because I remember us talking about it on the podcast when it launched. So,
Yeah, I remember us like talking, saying, yeah, it's coming, but I don't think, at least I don't think the KVM one quite was there yet.
yeah.
Anyway, we're definitely going off main topic here a little bit.
Yeah, as always though, we like to talk about it and kind of share that as an option for people who are looking for some inspiration. So yeah, some cool updates there. So we can move on to some of our other topics, including a vulnerability that made a bit of the rounds on some social media and whatever. So this was by Watchtower Labs and was a Fortinet vulnerability that was it's kind of a new bug, but kind of not. There's a bit of an interesting story there, but it also goes into the methodology and whatnot beyond the bug, which is something that Z has been trying to push for recently. So I'll let him cover this topic.
Yeah, I know you found this to be a bit long, and definitely for just covering the vulnerability for what it is. Core vulnerability here is there's an SN printf. It generates a string. That string, there's no escaping of inputs. That string goes into a system call, and you've got command injection. So, like the core vulnerability here, not super interesting, but they do walk through their process. And in this case, they were kind of triggered with a little bit of ahead of time knowledge, being that there was an in the wild exploit going around. There were indicators of compromise for it, indicating like it might give this sort of little alert, which didn't actually say too much. Like I think the alert was just like there's an unregistered device. Like the way Fortinet manager works is like device tries to register and then it's in an unregistered state for a period of time until an admin actually approves this new device. So you can't just like add yourself in. And so like there would be that as the indicator compromise. So it's not like that much information, but it is some information. And yeah, as opposed, they talk through how they try to basically refine that vulnerability. And they talk through some of the background here, figuring out how the protocol works, kind of reverse engineering it. Wasn't like they weren't like reversing the client or whatever to get that. They were to do a bit more, get a bit of a higher level view on it. But they go through that. And I liked seeing kind of their reasoning as they read through, like, okay, this thing stood out. As you mentioned, they looked, one of the first things they did once they were able to register, so they figured out the protocol, figured out how to communicate, figured out how to get something going, which was getting a device into this unregistered state, so still being able to communicate. And there's a little bit of effort that went into that because it did require having a certificate, because there is kind of the mutual authentication. Certificate has to be signed by the right CA, but they were able to extract that from another appliance, or could perhaps get something from the CA can be extracted apparently. Either way, like there's a little bit of effort on that, a little bit of a barrier of entry, but they walk through all of that, and then they start talking through like, okay, we looked at this binary, and they are just dealing with the binaries here. So a lot of the code is decompiler code in terms of the quality that you see here. And you just kind of see how they approach what they looked for. Because one of the things they want to find is, even as unregistered, what attack servers do they have access to, leading them into this put JSON command function, which they, instead of looking through all like the random, as they call it, spaghetti code that existed, they were hoping to find like a nice little jump table, and put JSON command actually had a jump table for some commands. So they went and they looked through the handlers for various commands there, and one stood out because it had a call to system. And of course, I'm saying that, and I've oh, there it is. I could not for the life of me see the system there in this code, but yeah, it has, as I was saying, it has this SN printf and a system call. So yeah, it kind of stands out because system is definitely one of those things when you see it getting used in general. You want to take a look at that, and being an SN printf right into it, with
Bit of a
no
code smell.
apparent, yeah, oh yeah, that's a code stink for sure.
Yeah.
Like, it's possible that they're doing some escaping, like you can't do all the inputs you want, but they don't actually seem to. Looks like source file name is controlled, but destination file name isn't. Either way, like when you don't see any clear escaping there, something's going on. And in fact, like the next thing they had to do is, well, how do we reach this code? They know this is this command, this SOM export, but how do you even get to that the put JSON command thing? Like, okay, how do you get there? It walks through again some of the reverse engineering, some of their thought process. So if you want to kind of see their flow, there's a lot of that information.
Mhm.
Ultimately, they end up doing that register. It's like they go through this get file exchange, which ultimately leads in there where they can provide the URL that has some/export and data being their command injection. What was also interesting out of this was that they found this bug, which gave them code execution or command injection, which of course you can then execute code. But when they did the patch diffing to see what the like to take a look at the vulnerable version of the code, see what got patched, they found that the patch was another SN and system, but not the one that they had found. And the one that they found, or the one that was patched was in a different bind, and they couldn't figure out how to actually reach that code. As far as we can make out, this is quoting, as far as we can make out, Fortinet just patched a chunk of irrelevant, in brackets, dead question mark code and left the actual vulnerability wide open for attackers. Which honestly does feel like some clients I've worked with in the past where they they see somebody is suspicious of some code pattern. It's like, oh, this must be the vulnerability, without actually figuring out, like, is this the same as the one that was being exploited? It's just like, this is bad. Because, I mean, this is still a bad pattern in general. It's not a very nice pattern. But yeah, it seems like they patched that. They didn't patch it everywhere. They didn't go and audit all of their SN printfs leading into system calls. They just did the one that maybe wasn't even the actual vulnerability. So I do find that one a little bit funny. It also led to this being kind of considered a secondary bug for the 40 jump higher, I believe. I believe the original one's being called like Forti jump. Yeah, Forti jump and then Forti jump higher for their second bug for this finding. Yeah, it's a bit of a weird situation. I've definitely seen that sort of reasoning before, where it's like you find something that's suspicious, therefore it definitely is the bug, um, even though it's not.
Yeah, it
And
seems like some vendors and developers just really struggle with thorough variant analysis, for whatever reason.
this isn't even necessarily variant analysis. This is like analysis of the original,
Yeah, no, I know, but I mean,
potentially.
the problem here is multiple variants. Like, if they
Yeah,
had variance analysis in place, like this wouldn't have happened.
yeah, and to be fair, like I've actually like started ignoring Fortinet bugs in general when we see them, because they do tend to be a lot of these very basic issues. And it's gotten to the point where there's so many that it's not even worth spending the time to look at. I will call out one thing that I do want to comment on. They mentioned here that some may criticize our release of this proof of concept, particularly the release of generic bundled by default by certificates. I was talking about the certificate thing needed before, but we're confident that's in the best interest of Fortinet manager or FortiManager administrators. I'd say it's in the best interest of security research. I've said this many times when it comes to releasing proof of concepts, when it comes to exploits. By putting the information out there, you're taking away the advantage that the attackers would otherwise have. The attackers have the benefit of like spending the time to figure out this information. And so the harder it is for researchers, because a researcher is going to be able to spend less time on anything in particular. Like in general, researchers don't just get to throw their time away without like having some sort of financial
I would just
benefit or
clarify
reason.
defensive researchers. Like, I wouldn't say like offensive security researchers aren't researchers, but you have a lot more time and resources typically to throw at problems in offense compared to defense. Because when you're working defense at these companies, like security is not really treated that important by a lot of companies. It's kind of just like, hey, maybe we should have a bit of it. Here's, let's deal with it, but let's not actually spend that much effort into it. So yeah, it's just that defense and offense sort of
Well, even the offensive researcher, like let's just take a good faith researcher is going to take a look at Fortinet's products here and do some of their own research on it. They're not getting paid for that time. They're not going to necessarily put in, like, they're going to choose whatever target of interest or whatever motivation they have for looking at a target. Maybe they're getting paid, in which case they do have a financial incentive, probably on a time box. So they're probably being like, you could look at this for the next 3 weeks.
Yeah,
And
that's
so
fair.
even the offensive researchers, like unless this is one of those like big hardened targets, which I don't think anything
I think
for
it's
that
fair to
gets
say
to
it's not.
qualify as.
Yeah.
Yeah. Like it's not something that the researchers are really going to be putting a lot of time in because there isn't a lot of incentive for those researchers. Like you tend to have those big hardened targets as like the targets of researcher or targets of
Targets of
significant,
interest.
yeah, because those are the ones where the vulnerabilities are a lot more valuable. On the criminal side, they're able to leverage bugs like this, and so they have the incentive of like maybe getting paid from their criminal activity utilizing these bugs, set up their Bitcoin miners everywhere, whatever they want to do. They have the financial incentive, but just the good faith researcher doesn't. And so making it hard, like you're leveling the playing field so that they're not having that advantage of time or being able to spend the time. And that's how I feel in general when it comes to releasing proof of concepts, releasing exploits, is you're removing the advantage that the more malicious attackers have because they're able to spend the time because they will get financially compensated. Whereas the researchers usually won't on targets like this, unless they're like being hired to look, in which case they're probably not being given as much time as the attackers would be anyhow.
Yeah. So another thing that I will add that we didn't really touch on is that even though that patch did not fix the like FortiJump issue with the system injection, because of some other modifications that were made to the code base, device registration is required now before the communication is possible. So they state like this has the effect of turning their vulnerability into a post-auth privilege escalation instead of like a full RCE like pre-auth that it was before. So, in fairness to Fortinet, there was a bit of like the defense in depth there that was done that sort of mitigated this vulnerability, even though it wasn't fully patched, which again, it speaks to the value of those defense in depth kind of measures. But yeah, I did just want to mention that before we move on.
Yeah, good shout. I mean, I kind of focus more on method than a ton of the details there, but it's definitely worth pointing out.
Yeah. All right, so we can get into our next post. So this was by Rootkit SMM, and it's titled Pishi Coverage Guided macOS K Extension Fuzzing. So this was sort of a like side project of interest for Rootkit SMM. He mainly does Linux kernel security at a job, and was like, I wanted to look at some operating system stuff. They didn't want to look into Windows, and that kind of leaves macOS as the final option. So what Pishi is it's a static macOS kernel binary rewriting tool, because part of the problem that you have with macOS, similar to Windows, is that you don't have the source code for everything, particularly the kernel extensions or KEXTs. So because of that, security research is kind of mitigated, because when you have like the Linux kernel and the Linux kernel kind of has some closed source drivers too, but for the most part, a lot of the drivers are open source. You can compile them. And so, if you want to do some fuzzing or something, you can compile the kernel with sanitization. So you can have like address sanitization, you can have coverage, which is pretty much required nowadays for doing any like in-depth fuzzing. You kind of need some feedback mechanism. But when you have only the binaries to work with, that's a lot trickier to do. So what they were interested in here was instrumenting the closed source drivers for fuzzing to get feedback, so getting coverage and whatnot. And the way that they do that is they essentially write their own kernel extension that implements coverage sanitization. So, like the sanitizer cov trace PC function, for example. And then they use inline hooking on the target kernel extensions that they want to fuzz to make the basic blocks in that extension call into their coverage sanitization. Now, that sounds somewhat easy, but it is pretty tricky to do in practice, especially because they don't especially know where their custom kernel extensions functions will be loaded to. So to kind of get around that issue, they had to mess with the loader a little bit for the kernel extensions, where they can basically get the runtime to fix up the addresses for them. And then with that, they can add whatever instrumentation they want to go with. So from there, they talk about code coverage, because code coverage in and of itself is not like super straightforward. You kind of have two notable code coverage metrics, being the classic control flow coverage. So whether that be like edge count, basic block count, things like that. But you can also have data flow coverage, where you instrument like compares, loads and stores, and all that. So the post goes into a lot of detail on how coverage sanitization works and how they do the coverage of basic blocks, as well as how to feed that feedback into the fuzzer and make it work with the fsanitize LLVM flags. There's a lot of great detail there. I'm not going to go into all of it. If you're interested in that, definitely give the post a read. But what I'll finally note is that Pishi as an instrumentation tool is pretty modular, and it seems like it can work with pretty much whatever fuzzer you want, whether that be libAFL or AFL++ or HongFuzz or whatever. You just need to implement a harness for it. So yeah, even if you're not super interested in all the methodology and how they did some of the binary level instrumentation, the PC in itself seems like it could be a very useful tool, especially if you're looking to do like macOS research specifically and want to look at some of those drivers. So yeah, I mean, great post. It is a little bit long, but it goes into some in-depth on how hooking works in ARM as well, which this might just be like a lack of exposure thing, but I haven't seen a ton of great posts that talk about hooking and doing that kind of stuff on ARM. There's like tons and tons of resources on doing that with x86, where x86 is kind of the popular architecture, but ARM is taking off more and more, even creeping into like the laptop space with Apple's M1 and now up to like M3 or whatever processors. So yeah, I mean, just a lot of great information here. So I would recommend checking it out, even if you're not specifically interested in Pishi. A lot of cool stuff here.
Yeah, as a post itself, like there's a lot of background, and what I liked about this was less interest in the actual tool. But when I talk about learning fuzzing and stuff, I always have a kind of a challenge because there's a lot of fuzzing resources out there where the focus is on like, here, take libfuzzer or take AFL++, and we're going to run it to find these bugs, and we're going to learn to use libfuzzer, learn to use a fuzzer specifically. And there's so much thought that can go into fuzzing, that just gets overlooked as like, well, what's the right flag for AFL++ to make this work? And what I really appreciate with this post, and this was one of their intents, was like to make this kind of accessible or make fuzzing approachable and interesting, even if you weren't necessarily coming from that background. And what they do in this post is they do talk through a lot of those decision points that could be made. How do we instrument the closed source targets, as Spectre was mentioning there, talks about like the hardware assisted options. There's the mention of like coverage or SANCOV. Uh, there's kind of those mentions there as like, here's some of the decisions, some of the options that could be done, why they work, why they didn't, benefits, negatives, like whatever. There's a lot of information here, and it's, when it comes to learning fuzzing, I think a lot of this background knowledge of like all the options is important, even if you do ultimately end up just going and using AFL++ or libfuzzer or whatever. Understanding your options, I think, is kind of important to like coming up with a decent fuzzer, and just understanding what you're doing rather than it just being about the fuzzer and like make the fuzzer work and fuzzer go burr. So yeah, I really appreciate this post. There's a lot of good depth here. It almost feels, it's not exactly like fuzzing from first principles, but they include like a lot of that foundational information that's just really good and well explained in here.
Yeah. So I guess we can move into our shout outs for the show. So yeah, our first shout out here that Z found particularly interesting was breaking control flow flattening from Zerotistic. So, control flow flattening, just talking a little bit about what that is for people who aren't familiar, because I wasn't super familiar with the term. I don't really have to deal with obfuscation a lot with like the typical work that I do. But the idea with control flow flattening is you take a function, like they have an example calculate function here, which has like a for loop and an if statement, and you have kind of your expected basic blocks where you have the for and it'll jump into a block or jump around it if the condition is met. But with control flow flattening, it'll turn that into a state machine. So it'll have like one jump table that will jump based on the current state, and it'll just update the state. And so it's not crazy, but it does make it a little bit harder to look at, because it's not obvious what's going on, and you kind of have to keep track of that state. And what this post goes into is using binary ninja scripting, and particularly the HLIL and MLIL intermediate representations, and basically automatically lifting from like the control flow flattened back into like a proper control flow graph. So yeah, very cool. It talks about how the Binja scripting API can be leveraged, and we've kind of talked before about how powerful that can be with those ILs. And this post goes into some detail on that and how that can be leveraged. So a bit of an inspiring post, and especially if you have to deal with a lot of reversing and obfuscation, could give you some ideas to tackle some of those kinds of problems.
Yeah, and while the specific algorithm in use here for yeah, trying to reverse the control flow flattening maybe isn't going to be relevant, maybe it will be, but the idea of doing this level of analysis, looking at the functions, like figuring things out from there, is something you may do in just vulnerability research in general. So definitely has that applicability. And also, I do recall when this got linked in Discord, Spectre, you seemed a little bit surprised at the choice to use MLIL. And so I thought I'd take a quick moment. Just I've talked so much about how I like the ILs, but I haven't really talked too much about what they are at any point. So I was going to kind of transition towards also just mentioning a little bit why MLIL I think is one of the more special things with Binary Ninja. So MLIL being the mid-level, you've got LLI. So you've got starting, like you're going to start with your assembly. And there's actually a Trail of Bits post that's kind of old. This is actually before high-level IL existed in Binary Ninja, but kind of shows some examples of these things. But at the baseline, you've got like just straight up assembly. That's your lowest level thing. Then low level IL is just kind of a very light rewrite of the assembly. The example I've got here is like you'll see like EAX and it just rewrites it as EAX equals EBX plus A. Just slightly more readable than assembly. You also get a little bit of conditionals where if there's like the test and test and then like a conditional jump or something, it kind of understands that enough to give you this little idea of what like the condition is using the register specifically. And pretty much all of Binja does include this S and then less than equals to like signed comparison or unsigned comparison, which is really useful because I know other things like you might have to hover to see that or whatever. It is nice just having that inlined, but low level ILs just is very light rewrite of the actual assembly. It's got like your memory stores, load and store, and like push pop for the stack for anything dealing with the
Yeah,
stack.
I like to think of it as generalizing assembly is like the main purpose of it. So that like if you have ARM and x86, they're both like, even if you don't understand ARM, if it lifts to LLIL and you understand LLIL, you're good. Um,
The registers can
that's
still
being
be,
a little bit.
yeah, registers can still be a little bit tricky on that because like ARM registers versus x86 registers are different and it just uses
Yeah,
register names. But it is that. Honestly, I just find LLIO nicer to read because you do just get like, it's not move, it's equals this. Like it just rewrites it slightly easier to read, more natural to read.
yeah.
And so I kind of like that. But mid level starts introducing a few more ideas where with The medium level, you'll start having, actually, I should have brought this illustration up a little bit earlier, but where you've got the assembly, looks like that, then the LLILs, very similar length and everything, just slightly rewritten. And then the mid-level version, you actually have the idea of variables in there, like that is determines that it's an int32t, has the idea, like, can do some heuristics, may be incorrect on this, but also has the idea of structures, arrays, and all your like primitive types.
Your
Has
higher level
the
types.
Yeah, has the idea of those. You have a little bit of the data flow analysis, so it knows like value ranges potentially. Not everything can be figured out, but has some of those things. But it doesn't go so far as to actually be like a full decompilation where you could just like copy this code. Still have a lot of cases of like, it's referencing maybe the registers or something like that. It also understands like functions, calling conventions, tries to figure out some of that also. So the MLIL, if you're doing an analysis, this is where it does start to feel a little bit, it's still an IL, but you're abstracted from the actual architecture a little bit, because it'll deal like conventions, like calling conventions and stuff. It's kind of dealing with that. You don't see the push and pops anymore. It's kind of hiding that from you. You can determine if a variable is on the stack or where it's located, but it's left as it's just a variable type that you can interact with in the API. But it doesn't have the optimizations yet that you'd expect an actual code when trying to figure out what the code is. So it's actually a pretty nice level to operate with, and is kind of the thing that if you go and read, like, Ghidra has P code, IDA I think has something also, I forget the name of it. They do have an attempt at an intermediate representation. So you've obviously got the disassembly, and you've got the decompiler options, and then you've got, like I said, Ghidra's P code, I think, kind of exists as their intermediate representation, but it's just that, and it's really meant to be like machine used, and they're just exposing it to be seen. Same deal on IDA, whereas Binja is kind of made for a researcher to be here. And so these are things that are useful for the researcher, and like if you want to write analysis tooling, it can be pretty useful. I'm not super, like, I've done a little bit of the analysis tooling, something I need to do more of, but yeah, I don't know. I'm a fan of MLIL. I don't think I've ever really showcased what these ILs are, because this is one of the things that Binary Ninja has and does that I don't think any of the other platforms do. Like I said, Ghidra and IDA both have an IR, intermediate representation, that's used, but it's not meant for like a human to really be reading.
Yeah, so I mean, you had mentioned my remark in Discord about not like being a little bit surprised by MLL. And yeah, I guess I shouldn't have been. But the reason I was, I guess, is like when I'm doing a lot of manual reversing, and like the main work that I do doesn't require a ton of complex reversing. I kind of touched on that when I was talking about the fact that I don't have to deal with obfuscation. But because of that, I don't write a ton of like analysis tooling that takes advantage of the different IL levels. Most of the work that I've done with the Binary Ninja API has been with like loaders. So you're dealing with actually getting everything loaded, and you're working at like the assembly level still. You're not working at the IL level. I have implemented lifting for, because something that's kind of nice about Binja too is if you're writing a plugin for an architecture, you lift to LLIL, and then Binary Ninja does the rest of lifting that to medium level and high level. You just have to bring it up to that first low level. So that's where most of my work has been. So typically I'm looking at either like assembly, low level, or high level when I'm trying to, do reversing. Medium level is kind of in that weird like middle area where I just don't really need to go there usually. But it is a fair point that like when you're doing the automated analysis, it's kind of the perfect level, because you have that abstracted view of the code, but you're not dealing with the inaccuracies that you can get at a high level. So yeah, I mean, I should have expected it, I guess, but it is sort of a weird middle child, so to speak, that you don't really immediately see the value in it, until you're doing some of this kind of automated analysis.
Yeah, and I mean that's kind of true with I think a lot of the ILs in general. Like you don't necessarily see the benefit until you start trying to work with it. And it is worth noting in the original post here, like they do make use of high level IL for like the variables and mid level. So like they mix and match both of these in their analysis. It's not that you have to work with just one or something, but um yeah, I want to kind of use this as one as a shout out. Like you, I don't do um a lot of reverse engineering where this would be relevant, but I still found the post to be fairly interesting.
Yeah, for sure. And on that same topic, we do have a few other shoutouts to bring up in the interesting category. One of them is a vulnerability actually in Firefox. So I'll let Z get into some of these shoutouts and then we'll wrap up the show.
Yeah, so Firefox animation shout out. Kind of just it's a browser bug. It's in Firefox, so it's not Chrome, it's not like the VA bugs. Feels quite a bit easier to understand kind of what's going on here. It's just a animation use after free. They've got these ref counted animation or kind of a re-entry sort of bug where you've got the animations, you've got an animation timeline. So the animations have a reference to animation timeline. The animation timeline has references back to the animations that are relevant, but it also creates this linked list of the raw pointers that aren't reference counted. And then during ticks, you can end up back in JavaScript. And so you can actually have Java. So I forgot to mention JavaScript is holding kind of the root references to the animations. And so what can end up happening is during a tick, you end up having the animations get freed in JavaScript, but you've still got these raw pointers that were collected while running through like in the animation timeline. So when it returns, finishes a tick, goes to do something, because those raw pointers aren't reference counted, they end up getting freed because it doesn't know there's still something holding the reference, and you end up with a use after free scenario. They go into more detail, of course, of the bug than I'm going to here, but it's one of those browser bugs that's a bit more approachable because frankly, because it's not V8, it's not like some optimizer bug or something. This is a more logical, well, it is still very much a browser bug. I don't know, I thought it was at least a bit more approachable, decently written here, a bit of information on it, so wanted to give it the quick shout out. And then the other shout out we had was just Quarks Lab. We've covered a number of posts from them in the past, including from interns. And I saw they have their internship offers here for 2024-2025 season, which now that I'm thinking about it, feels a bit wrong for 2024. To be an intern in 2024, you don't have much time left to yet apply. So that maybe feels, or maybe they're talking about like student year being from 2024 2025.
Yeah, I think it's student year.
Yeah, that just kind of hit me, and I'm like, is this an old post or something? I guess this is from October. Nonetheless, they're doing internship. It seems like they let their interns do some interesting research, so I want to give them a shout out. It is there. You must be a student, unfortunately, but it is a chance to do some vulnerability research in a sense, or some low level research, not necessarily vuln, but that is one of the things that they want there, or vulnerability assess. One of the topics they're kind of looking at is vulnerability assessment and exploitation of satellite communication systems. So yeah, phone research, some information in there, or I guess one that's filled already is exploit dev related. Anyway, I figured I'd give this a quick shout out because I think it could be interesting to some of you who are trying to get into the field.
Yeah, I think it's great for, getting your feet wet and building some of that initial knowledge. The best way to build knowledge, I find, in this industry is to rely on other people. And, kind of the common saying that I've seen thrown about in these kinds of conversations recently is try to make sure you're not the smartest person in the room. You want to kind of leverage the expertise that other people have and kind of soak it all in. And these, like, working at these kinds of places, even through an internship, is a great way to do that. So
yeah,
if you can take the opportunity and you're interested, then yeah, I think it's definitely worth jumping at.
Yeah, I don't know how competitive their internships are. I do know these can be they can have a lot of applications come in. I think of the one place I worked where it's like, I want to say we had like maybe 4 to 6 interns and like 1,000 applicants. So like
Damn, I
very,
didn't
very
realize it was that competitive
competitive.
actually.
Yeah, like I remember I wasn't super involved there. Because the interns were based in the office I wasn't in, but I do remember hearing like some pretty massive numbers on that. And so I don't know what they're doing, but I think you've also kind of got the case where you get a lot of applications from people that are interested in security, but don't really have. I mean, I don't want to act like you've got to have like some really strong security background to get an internship, because the point is like an intern is not necessarily experienced, but I get the feeling that a lot of applications are just like, oh, it's security, therefore apply, and not necessarily somebody that's even going to go into security, just seeing the opportunity. So, yeah, I don't know what their numbers are like or anything, but it is worth noting that I think some of these can get very competitive.
Yeah. All right. So with that said, that's all the topics we have for today. So as always, thanks goes out to everyone who tuned in, and we will catch you next week.